So hi, I'm Chris. I'm an engineering manager over at Sainsbury's in Manchester. So I'm going to talk to you guys today about kind of an introduction to GraphQL and a full stack point of view. So if you've not used GraphQL before, kind of a bit of an introduction to what it is and what it's for. So in a slightly provocative sense, this is what they say, that GraphQL is the better REST. I'm going to step that back a little bit because I know it's a bit controversial. But essentially, you're probably used to traditional REST. You have endpoints, you get those JSON back from those, or XML, whatever, and it's kind of get what you give an approach. So if you want more data, you have to fill in or hit all the endpoints. You kind of tied to the schema you get back from that. So you kind of have these problems of overfetching and underfetching. So you either overfetch and you have to go get things multiple times. You underfetch, you can't get all the data you want. Also, you start to like versioning, and it kind of works fine. But some companies found these pain points that make it quite hard to iterate. And GraphQL exists to kind of fix some of these pain points and do something slightly better. So this query in GraphQL looks like this. So rather than multiple endpoints, you get one single endpoint that every single query goes through. And to that endpoint, you give it the fields you want to select back. So you can see here, you've got the same query, but it's multiple types, multiple nested relationships, and you get back exactly what you asked for. And that means you can kind of not overfetch, not underfetch, and it means client developers can kind of iterate really nicely and try new things. The data stays the same, the graph stays the same, but you can try new features, you can try new ways of getting data, you can play around it a little bit more. So much more rapid incremental development. So I said this was kind of from a full stack GraphQL perspective. What's full stack mean? Because I know everyone's got different ideas of what full stack actually means. From this point of view, we're going to look at GraphQL from a database, API, application point of view. So we're going to build something, it's mostly going to be a demo, I'm afraid, that will hit the front end, an API, and also get some data persisted. We use a few tools for that. So API, we use something called Apollo Server. Front end, something called Apollo Client, and the database can be something called Prisma. So those are the three tools we're going to use, and that's about all the slides I'm going to get, unfortunately. So I'm going to dive straight into code. If you guys got any questions as I go, just shout out. I'm happy to kind of answer as I go. It's going to be mostly JavaScript and a bit of React. So if you've got any questions about what I'm doing in those two things, do shout out. I know not everyone knows React, but hopefully it should just be mostly JavaScript. So I've got a really simple blog built in GraphQL. I'm going to make that a bit bigger. So this is currently a React blog. So it's got some posts. You can click into those and you can see some content. Really simple, sort of 2 pages. And what we're going to try and do is make this hook up to an API, persist some data, and get some stuff out of it. So the way that GraphQL works is you have fields, you have objects that have fields. All these are strongly typed. So the first thing you have to do is just define what those fields, what those objects are, and how they relate to each other. And you do that by way of what's called a schema. So the first thing we're going to do is going to build that. So again, is that big enough for everybody? Everyone read that okay? The colour's a bit odd, but hopefully that's fine to read. So I've very cheatingly prepared a schema in advance. I know, sorry about that. It's not all live. So this is what a GraphQL schema looks like. So you have object types, so type post, type user. They have some fields, and all those fields are strongly typed. You can see some required, the exclamation mark, and you can see at the top we've got a post that's an array. The top type is a bit of a special thing, in that that's the root node of your graph. So every query you do goes through that root node. So at the moment, all you can query is posts. You can get that out. So we're going to try and build an API that fulfills this. And it shouldn't be too hard to do. So first off, we need a few dependencies. So this is where I'm really hoping the network doesn't fall over. So we're going to try API. We're going to install Apollo Server and GraphQL because we kind of need it. So Apollo Server will kind of give us the tools to fulfill that schema as an API. Oh good, it's fast. So just to show we've got some kind of static data here, just to get us started, that we're going to kind of use as an existing point. So we've got some posts, we've got some authors that are linked by ID, and some kind of really horribly written utility functions to get that data out. I'm not going to show you those because they're awful, but we're going to dive straight into the server. So let's import some stuff. Sure?
Was that Pirate Ipsum?
Pardon, sorry?
Were you using Pirate Ipsum for the...
I was using Pirate Ipsum. Yeah, well spotted. It's better than Lorem Ipsum, and it's, so yeah, we're going to import GraphQL Apollo Server and GQL, which is kind of a tagged template function to let us do some translation on the GraphQL bits. And let's create a server. So server takes some type definitions and takes some resolvers, which for now we'll leave blank. Type definitions is the scheme we had before. So if I just grab that, you can import these. For sakes now, I'll just whack in a string. You can kind of separate these out a little bit as well, so you can kind of make things to different modules, that sort of stuff. But again, there's only 2 types, so we don't really need to do that here. And then we'll make this listen. So hopefully, if I go back to my API, what have I done wrong? Oh yeah, I need to require the thing, that would help. Yeah, I do apologise for any missteps in the live demo, because it is live, so. Cool, so now, if we go to our API port, we have a lovely playground which should show us. We have a self-documenting schema we can dig into. We can see what's there. Post is our root endpoint. We can dig into that. We can see what fields are on posts, on user, and kind of interrogate that a little bit. So kind of GraphQL APIs are self-documenting because that schema is strongly typed. So it gives you a really nice way to browse those and see what you're going to get. So let's try and query that. So let's post out. So that's going to get nothing because at the moment we have no data. So I'm going to show you how to hook that up to get some data out. So I mentioned you have some resolvers. At the moment they're blank, so what we'll do is we'll fill these in so we can get some data out. So resolvers are essentially functions that sit on an object. So every type you can define resolvers for, and that will resolve the fields on that object. So we're going to resolve some stuff off query. And on query you have posts. Each one of these is a function that can do whatever you want it to do. In this case we're going to use some utility stuff to go and get posts. We're just going to pull back our data from this array, and you can see the fields we've got here mostly match up one-to-one to the field names we've got on our schema. So when I resolve this, we have some titles back. Or if I try something slightly more complicated, like I want to get an author, and I want their name, it's going to fall over. Because at the moment, our data has no idea of an author. It's got some IDs, which is great, but it's not going to get that data out. So as well as resolving that, we can resolve stuff for post as well. Let's try that. So we're going to post author, and we tell the API how to get data back about an author for a post. So again, that's just a function. So the function signature for resolvers takes 4 arguments. I'm going to show the first 2 now and the second 2 later. So the first one is essentially the parent node of the thing you're resolving from. So in this case, the parent of authors is posts. So I can go post. Then I can do get user post to author ID. So I can use that function to go get the information out based on the parent it's resolving off. So I do that now. We have some authors. So you can do, again, whatever you want there. You could go get some database, but again, we're just using straight JSON. So as well as kind of straight queries, we can also do some stuff with arguments. So we've got a blog that's got a list of posts. We want to get data about a specific post, so we need to provide that option. So let's do a post field. So all fields can take arguments as well. So in this case, we're going to say we're going to take an ID. You might take a slug here, you might take something else, but for this case, it's just an ID. So that ID is required, so you have some validation on your input types as well. And we say let's return a post. Because it could 404, we won't say that's required. We could null it out, that's absolutely fine. And again, if I try to resolve that, it's going to fail because we've not defined the resolver for it yet. So I mentioned the first argument to these resolvers was a parent node. The second is a list of arguments. So I can do get post args.id. So that's just an object containing the fields you pass through as input arguments. So run that again. We should have data post ID title. So that's, I guess, in 5 minutes, a really quick, simple API up and running. Before we move on to front-end stuff, I'll come back to this, don't worry. Any questions on what you've just seen, any other bits and pieces? Or sure.
Yeah, so you say I haven't written a resolver yet.
Yeah.
In the real world, when you build an API and you don't have a resolver for a particular query, because I guess the power of GraphQL is that you can query whatever you want.
So if you've not got a result for a specific query, so that's where nullability comes in, I guess, where you could null some stuff out. If you have to have some back, you make it non-nullable. Then if the field nulls out, the entire parent node nulls out, and that cascades up. So you can kind of say, you can give some error tolerance to say, this can be null, everything can still work, so your front end can kind of survive without this bit of data, or it can't, and you should error state in your front end, or your client, or whatever.
So you would prefer return default value, so
You couldn't. I don't think you can do default values, but you can basically treat that. You can make it null out, and then your front end you could use default, or you can make it handle it in different ways. So it's kind of up to you to design how you want that to work.
the query, standard practice is the query is successful in any way.
Yeah, exactly. It will be successful, or it will null out everything and complain at you. And it will contain. So if I do an error there, you can see it will have an errors field as well. Anyway, it's null. It will at least try to resolve most of it, so everything resolves independently. So it will try to do everything it can. But yeah, error handling is a wider topic in GraphQL and how it's made consistent. Anything else before we move on to some stuff?
Could you go back to the other screen?
Yeah, there's code.
Yes.
Yeah, sure.
The exclamation marks, what's...
So that's null versus non-null. So if it's exclamation mark, that means it's required, it's non-nullable. If it's no exclamation mark, it can be null, and that object will still be fine.
Okay.
So you saw before when author was nulled, it broke the entire thing because it was required. If we made that nullable, it would have got the rest of the information and said author's null because we can't get it.
You've got author underscore ID there. Is there a field author underscore ID, or is there?
Yeah, so that's just based off the data here. So that's from there.
Right.
Yeah, that's just kind of just the initial go with it. So that's just show that you can link off when you can't resolve stuff. You can pull from a different thing. You wouldn't normally do it from a static array for obvious reasons, but just as a quick demo. So we have an API. I'm going to try and hook this up to this and kind of use this with some data from our API. So I've got a really simple React app set up. It's got some material UI stuff in there. It's got React Router. If you've not used that before, it kind of just allows you some URL routing in your React application. And it's got 2 pages. One's a home page, one's a detail page. So we're going to make those 2 pages kind of sync up with the API and pull some data back. So the first thing we have to do is, again, install some stuff. Let's do that. So we're going to install GraphQL and a package called Apollo Boost. So Apollo Boost is kind of a super package. It contains your client, some caching stuff. It contains like GraphQL tag, basically all the stuff you need to get started with Apollo client really quickly. It's quite nice just as a quick, fast way to get going. So that's finished, hopefully quickly. Cool. Let's hook this up to our API. So I'm going to cheat a little bit, I'm sorry, because I can never remember these imports because there's a bunch of them. I'm going to pull these into our index.js. So we've got a client, we've got a provider, a link, and a cache. So we're going to create a client. A client takes a cache, which we can create a new in-memory one. So that's kind of similar to the Redux store. You can kind of store stuff in it, you can pull stuff out. You can like interrogate it when you do mutations and pull stuff out of it. We're not going to do that now because it's more in depth, but you can play around that a little bit. And we take a link. The link is essentially how you tell the client how it can go get that data. So in this case, we're going to create an HTTP link, which takes a URI, which is the URI to our server. And then finally, we're going to replace our root of the app with an Apollo provider, which takes a client, and wraps the entire application with that. In the same way you have like a Redux store wrapping your React application, it works the same way, so it passes the Apollo client down in the context. So any component under that can be like GraphQL aware.
I think you've got a little closing bracket there.
Yeah.
What's that, sorry?
The closing brace for client.
Oh, thank you. It's great getting like live debugging from a crowd. Thank you so much. This is basically just massive mob programming. So great, we've got our application hooked up. Hopefully if I go back to that, it should still work and I'm not broken anything else apart from that. So yeah, you can still go into that, you still get stuff out. So we're not actually fetching any data yet, so let's try that. So we go to our home page, you can see we've got a home component that's pulling some data from some static data again. So let's get rid of that. We're going to import a component called query from React Apollo. And we're going to put our template tag from GraphQL tag. So first thing we need to do is define the query to get this data out. So we had some posts, we had a title, we had some content, we had an author. So we can go to our playground, we can build a query that does that. So we want posts, we want a title, we want an author with a name, and we want an ID, because React needs to key it off that. Oops. So that should get us the data we want. So we can literally just grab that and whack it in a query. So we can say home query. Oops. And all we need to do is wrap our component with a query component that provides it with some data. So query, home query. So we provide that query to it. And then rather than directly use our component as a child component, we use render props. So if you're not familiar with this, basically passing a function as a child component. And that function has one argument, which has 3 properties, which is loading, error, and data. That should return us our home page. However, if I load that now, I should hopefully get an error. First time I've said that for a while. So we get an error because it's not got any data. And the reason this is happening is because that component renders every single time. When the query is still running, you have no data. So that's where the loading error come in. So we can say, if loading, return, and it says it's loading. If there's an error, return the error message. If I break that again, you can see that should render 3. So it's not a great error, you can make that better, and you can do this in like a higher order component that wraps this sort of behavior, but for now we'll just do it in a really naive way. So I get rid of that intentional error, you should hopefully have some data from our API. So we've got a query defined, it passes it down through the query component and into our components. Any questions on that before we move on to the next bit? Shoot.
Yeah, so your Apollo provider, is the idea that that would like replace Redux then? Is that stored instead?
You can use Redux as well. So the stuff we do, we use a different client called Relay, which has a similar store, but we end up using Redux for like small bits of application state per component, like per page, kind of what it's quite nice to do, rather than keeping the entire application state in Redux, which is kind of what the Relay store or the Apollo store is kind of for. But you can, I think you can, Apollo's is a bit more featured, so you can replace it. I've not done it myself though. Cool. So we've got our homepage working, but we've still got our detail page to do. So this is really similar. We've got some data we pulled through, and we've got a post detail page that does the same sort of job. So let's do the same thing. Let's go get a query that will get a single post. It's post ID 1. It's got a title, it's got some content. That's all we need for this one. So let's find our query. That's actually import the stuff we need. So again, we need the query component. We need the tag from GraphQL tag. Cool. And again, we can wrap this. I'm going to cheat a little bit. Sorry about this, because no part wants to write this twice. So again, we wrap it with the query component. Put that post query in there. I'm going to return this back. So again, we don't need to do this data posts messing around here because we have our post here. We can use data post. So that data object is just basically the same JSON you get back from the GraphQL API. So in this case, data is there. You can alias this. So you can do this and data this if you wanted to. You wouldn't want to in this case, but you can call that whatever you want. So I rerun that. Thank you very much. So we've got some posts, but as you might have probably noticed already, we're going to go to that one. But this one's exactly the same because we're crossing through ID 1 every single time. So that's not obviously not ideal. So how do you make that dynamic? So rather than using sort of straight naive queries, you can actually name your queries in GraphQL. So we're going to do that now. And as part of that, you can get some variables you can pass through. So we can define a variable called ID, which you can type, that's required because we kind of need it for this. And rather than ID, we can pass through our variable there. What that means is, as part of our query component, as well as just a query, you can pass through an object containing some variables as well. So let's create that. And our variables are going to be ID. And we use our React router bindings here to go match.params.id and get the ID out of the URL. And now, fingers crossed, we have it linking up with the variables we need. So rather than having a different query per page, you can have a sort of static query but pass different variables through at runtime, which is kind of cool. So we've got stuff reading from a list. We've got a single page reading. The last thing we're going to try and do is some mutations, so actually change some data. I'm not going to do this from the front end point of view because it takes a bit of time. It's kind of similar how you do the query component and you wrap it up with a mutation component. It's just a bit more fiddly to demo, and I've only got half an hour, so I'm not going to do it, sorry. So, back to our API. In the same way we have a query type on the root, we can also have a mutation type, which defines all the things we can do to change our data. So we're going to create one called createPost, which takes some arguments, in this case an input. And you can also define what this will return back. So in this case we create a new post, we want it to return a post. So the input types are slightly different. Most types in GraphQL you can do some polymorphism on, you can get unions, interfaces, that sort of stuff. Input types you get none of that. They're much more like of a bag of stuff to pass through to mutation really. So we want a title, which is a string, some content, which is also a string, and author ID, which is an ID. And again, if we go back to my playground, we should hopefully see if I refresh this. We have a mutation, which again is typed. We'll tell you exactly what it comes back with, what you need to pass in there, and we'll strongly type those arguments for you. But again, if I try and call that, just do one for now. I should return some stuff back, so I should get a title, an ID. If I try and run that, it's going to go to null again, because we've not resolved it yet. So in the same way you can resolve stuff for queries, the resolvers for mutations work in exactly the same way. You have a type, and you have your fields on that you resolve. So createPost has a parent, which in this case is the root, some arguments. And we're going to do some work with that. So we're going to get, our title, our content, and our author ID out of our args, which is in the input option of the args. And we're going to use some utility functions here to go create that. And again, it's really important to note with these resolvers, you can do whatever you want. So a lot of people kind of go, how do you do caching in GraphQL, how do you do authentication, how do you do all sort of stuff. If your functions can do it, you can do it. You completely got power to do whatever you want in these functions. You can call off to Mongo, you can call off to a database, another API, whatever you want to do. As long as you can do it in JavaScript or whatever application you're using, go for it. So hopefully now, if I create this, I've broken it. Because I've not put a comma in, let's fix that. Every single time I do this, I do that. Make some posts. If I refresh our homepage, we have, this is a test post. So we've mutated our array, but of course, we're kind of cheating at the moment. So if I kill that server, restart it, it's going to go away. So the next thing we're going to do is try and persist that data in a database. Any questions on that before we move on? If we want to see you again? Awesome. Cool. So, back to slides a little bit. So we've got this, a database, I've got a client, we've got an API. The database is going to use something called Prisma. So what Prisma is, it's a way of generating a fully compatible CRUD API around a database in GraphQL. So we're going to use some tools to generate that for us. Let's come out of here. Prisma, init, call it our DB. So we're going to use a Prisma client, which is actually just out of beta. So it was released about 3 days ago. So this is all quite new stuff. So I'm not fully familiar with it, but it's pretty cool. So we can use an existing database for this. Give some options. We can connect to like a Postgres database or SQL database, whatever you want to use, or we can create a brand new database locally. So you can host this wherever you want to do. But for this demo, we're going to use their hosted services and get a demo server. We're going to use EU because that's a lot closer than US. We can call it DB. Our stage is dev. Then the cool thing that's new is you can generate a ready-to-go Prisma client based on whatever language you want to use. So it's JavaScript, TypeScript, Go clients. For now, we can use JavaScript. And what it will create us is a folder containing some configuration. So we've got our endpoint there, we've got some other bits and pieces. I'm going to quickly change that to generated client to point to our API. But the most important part is our data model. So this might look quite familiar, and it's just a GraphQL schema. But it has got a couple of annotations on there, so well, one annotation. So you can see ID has got a unique field in it. So it's got a few of these. For now, we're just going to use that one. But basically, this is just an annotated schema that defines your objects and your types. So we're going to pull in our schema from before, or just the post type, because it uses exactly the same. We'll say IDs are unique, because they really should be. And all we need to do is Prisma deploy, and we should hopefully, in a minute, get a brand new working API. So you can see it's detected the types we've used, it's generated the relationships between those two as well. So post to user, and it's given us an endpoint as well, and a client. So we jump to that. We get a playground again, and you can see all the sort of stuff you can do. So create posts, update posts, delete them, get connections back, get individual nodes back. So it's completely fully featured. However, you don't really want to expose this to clients. In the same way you wouldn't expose a raw database connection to clients, this is way too powerful. So what we want to do is proxy it. Or in graphical terms, we want to bind our resolvers off to this API. So I'll show you how we can do that. Let's quickly create some content. So the way that Prisma works is you can create data and link data at the same time. So we've got a title for our post, a content. At the same time as we create that, we're going to create a new author, me. Let's run that. So that's created our new post. And if I go pull this in the database, there we go. That's our data stores. So I've already got a working, persistable API in GraphQL, which is really quick. But how do we actually use that? So I mentioned it generates as a client. If you look at our API, we suddenly have this Prisma folder, which contains the enormous schema Prisma generates for a simple schema. So that's got all the sort of stuff you can do, including loads of like generic filters you can do. So it's very much like an ORM for GraphQL. And it's then got a client in JavaScript. So we're going to try and use that. We have to install one dependency, which is this one here. So that's running off. And then in our API, we're going to pull that in. We're going to do const Prisma equals require, then we're going to require our local client we've just made. So we created a server before with some type definitions and some resolvers. This can also take a third argument, which is a context. So context takes a function, that has a request in. We're going to return that request back. We're going to also pass in our Prisma client as a part of the context. I mentioned before we have some arguments to these resolvers. The first two are our parents. The second one is parents and arguments. The third one is that context object. So every resolver now has access to our Prisma database. So for our posts, we can now do parent args context and say context db posts. So essentially you can delegate off your endpoints or your fields off to the Prisma fields. As long as it's on the root of the Prisma schema, you can delegate off to it. The last part we can do is the fourth argument, which is the info. This is essentially the information about the query you're performing on your API. So it contains the AST, like the abstract syntax tree. It contains the fields you're selecting, loads of information about what you're doing. So we pass that along to our query with some variables. Prisma will know what we're selecting at the same time. So now we've created a post in there. If I go back to our local API, try to get some posts out, that's from our database. So we delegate it directly off from our API to a database in about 3 lines of code. And now if I update this, we're going to get an error because our author field is still trying to get it from the local store. So let's fix that. So again, we've got author, post, args, context, info. Becomes quite a common pattern. And we're going to go get our Prisma object. We're going to get the post that we've got from this one, so that's the parent object. Pull it out. There's this nice fluid interface. Oops, that's wrong, sorry. ID, post.id. There's a nice fluid interface that lets us pull the auth that post. And Prisma, the client will be clever enough that it will kind of transpile that into a single query rather than doing two. Is what they say. I haven't tested that yet. So now if I refresh this, there's our post in the database on the list. Again, that's going to fail because obviously that doesn't exist. So as well as using the parent, we can delegate from the arguments as well. We use our, again, post exists there. And this time we're going to pass some variables through and say id is args.id. Pass our info. Oops, make sure we're using context info first. And there's our database pulled in post. So you can see how quickly you can kind of use that as a graphical driven backend to do this sort of cool stuff with. The final thing we can do is we can also delegate off our mutations. So the same way you've got the queries you can use context and info to do the same thing. So we're going to do context db create post. This is going to take our data, so we're going to do title, content, but then for our author, we don't want to create one this time, we've got an ID already. We want to do author connect, and connect it up to our author ID. So now when we go back to our local playground, let me just name that query for a second. Nearly there. We can do create post, our input, so we're still using our same API, so our API that our client uses hasn't changed, even though we're resolving it from elsewhere. Got a title. Some content. For author ID, let's just go pull one from the database. Oops. That's complaining at me because it's validating the entire thing. Let's grab that out for a second. So author ID from here is a string here. We're going to get back a title and an ID. And that's our test post. So now we should be able to go back to our app. And that's our test post. Created twice, but still. And there you've got mutations working, you've got queries, all end to end, so you've got that entire stack. What you end up with is something like this architecture. So we've got a client using Apollo client that talks via GraphQL to an API. That API uses Apollo server. You've then got a Prisma binding that talks via GraphQL to Prisma, which then talks to the database. However, you don't just have to do that. You can have multiple bindings to multiple different things. So if you've got a database you want to use, great. If you've got some microservices internally or some other bits and pieces, you can go after those as well. So you can resolve some things from one place, some things from another. You can resolve them from GraphQL as well. So you can write your own bindings to your own services. So a lot of people are using that API layer as kind of like an API gateway, having one big GraphQL front end, talking to lots of other microservices, also speaking GraphQL, and just delegating that to whether BBC are doing it, Sky are doing it, lots of people kind of using that as their gateway layer. So then you have one consistent layer that all clients talk to, using the same language, using the same terminology for things. It's quite a cool way of working. Let me show one more thing if we've got time to show it. Am I okay for time?
Go for it.
Cool. So Apollo's got a load of cool features. It can do some usage of information, so it can show you how much people use what field, so you can get some information about that. It can tell you if you change your schema, hey, 8% of your clients use this field, don't delete it because that'll break them all. It can do stuff like persisted queries, so you can query your API via CDN and use just a string to get the same query names and speed things up massively. I'm going to show you something called GraphQL tracing though, because it's the easiest one to show and it's really cool. So as one more argument to our server, we can say tracing true. That's it. That's all the code. However, what that gives us is when we query stuff, we get this, which will give you per field information about how long each field is taking to resolve, work out how long each one takes, so you can really drill down to performance. If you've got some stuff that isn't working, because each field is resolved completely independently, you can see exactly what everything's doing and tie down where your performance issues are. awesome. I really, really like that. We unfortunately can't use it because the server we use doesn't support tracing yet. But all you need to do is annotate the stuff that comes back from your API with the right fields and right information, and it supports any server then, which is amazing. You can also use Apollo Engine, which hopefully I'm going to try and log into and show you quickly, which will pass that information up to a sort of shared dashboard. You can see what people are doing as your users. So I quickly onto this. Let's go into last week. Oh, that's Pro. Oh no. You have to pay for it. Oh no, I've lost my data. Anyway, you can see that same data, but for all your clients, and you can see, if you name all your queries, you can see which query is performing best, which you use most, and you can really drill down to how your app's performing. And that's pretty much as far as I'm going to go. So there's way more you can get into, that kind of gives you a full-on client database way of using GraphQL. So, any questions? Yeah, sure.
Did you have some sort of Visual Studio Code plugin that was like extra?
Yes. So there was execute in the query. For these bits, I've got some plugins that will give me nice type hinting with this. You can do some cool stuff if you have a certain config file in your root that will also then go query your server for you and tell you what you've got as you go, which is kind of nice. I've just not set it up for this API. You can also pull out anything from your query and use it like as TypeScript bindings. So you can get full types systems from your API through your network layer and then use the same types on your client, which is really cool. Yep.
And if you had, could you run the client from no backend if you needed like in the mid-line? Well,
Yeah, you can. Yeah, could do, yeah.
obviously could use reactive so much. But
Yeah, there's a few. I think there's another one I forget the name of that's built more for that. Like the Apollo one is kind of built to hook up to like Vue or React. But I think there's one that I can't remember the name of. I'll try and dig it out for you. That's way more just as like a client from another server. But the bindings work quite well for that. We've got some stuff that calls things from like a Lambda, and we use the bindings to go do that because then it's just an object that you call methods on rather than trying to do network requests.